So I called Paola from Università Milan, full professor at University of Milan-Bicocca. She will bring the other side, maybe, what David didn't talk about. So designing new product processes by learning from biodiversity. You can use one of, and you can also use that one for the slide.
Can you hear me now? Yes.
Yeah.
You can. Okay, good. Just 1 second. That I try to. You can. Wow. How should I? Next should be? Okay, fine. So thank you very much. So how much do I have? 2 minutes for my presentation? Yeah. Okay, good. Also because I was asked to do something like a TED Talk. So go in this direction of giving you some inspiration or some, I would say also something that is not maybe still said in these days, as it was pre-announced. So first of all, I would like to say that University of Milano-Bicocca is really glad to be a partner of this initiative. And these 2 days were really interesting for me as well. But then what we can say maybe that is rethinking, it's a never-ending challenge. This, I think we all agree after this work that we have done. But what I also have to notice, and I was not, let's say, contradicted this morning, is that when we think about constructing, we are always thinking about activities that start from our hands and involve the fact that we are, let's say, the actor of this transformation. Also, when we think about recycling, upcycling, reusing, it's always really centered on ourselves. So I want to be a little bit provocative with you now. And my question is, are we sure that we are not still as biased as long time ago? Because this picture comes from 1509, you see. And this was the pyramid of our living planet, as it was taught. So you see that humans are at the top level. And then you have this hierarchy, this pyramid, with a level really separated. Obviously, the animals are not as us, so they are just below, and then plants, so you see plants, who cares about plants? And then in the bottom, it's really, let's say, the unliving material. So we are talking now about material. It's really at the bottom. So it's like so far from us. And all these levels were like separated. And I'm wondering to myself, asking myself, what do we want to do? So we still have this concept in our mind or not? And how can we do to make this change possible? Just trying to work together with our planet and not like against our planet. So we should do like maybe a step forward. And this step forward actually happened many years ago, because there is something really missing in this pyramid that is so important. And this groundbreaking moment happened around 1687 is really 33, the letter. And because some talented scientists, and one was even not a scientist at that time, invented the microscope. And because of this invention, out of the blue, it happened that they discovered that microorganisms exist on this planet. And to be honest, they are the major biomass of the planet. And I myself discovered that about 20 years ago, because before I was hoping to study big mammals like dolphins and whales. And I was not considering this little one. I thought, yeah, they are little, so for sure they are not important, but it's not. Because they were the first to come to this planet, actually when it was sterile. It's just because of them that the Earth became as we know it now. Because they are transforming. At the beginning when they came, there was no organic matter. It's just because of them that they started to transform. It's what they are doing right now. And they had about 4 billion years to develop their biodiversity and to learn how to work with our planet. And the macroorganisms just came 600 million years, to have this biodiversity. So maybe we should learn something from them, and maybe we should recognize to them that their biodiversity makes the world go round. So I will not go in detail, but I just want to mention that they can really transform materials, and they can really connect the biosphere with the sphere that is not so abiotic sphere, And this is because of them that we can circulate the material. Yesterday, we talked about one of the boundary that we passed that regards in the nitrogen and the phosphorus and also the sulfurs is mirror election. And we can really learn from them. So how many lessons we can learn from them. And so you might wonder why they are so wonderful. And it's because of their metabolism. So they can eat more or less everything, even the substances that we can, we know that they are recalcitrant. Even, some years ago, it was discovered that some bacteria can also eat plastics, and you will talk about it today, very likely. And so you see, they can eat more or less whatever, and they can transform it in something else that either we can use or become food for someone else. And this is how they make the things go around. And because of these beautiful activities that they can display, we can even imagine really to ask for their help and to work together with them and not against to achieve some of the things that we have said in these days. So for example, the upcycling that relates to something that for us at the end of life. For them, these kind of things that for us are at the end of life, they are just constituted by molecules that are food for them. And they can transform these molecules in something else. And so this is what I'm working with. And so in a sense, I'm learning every day. And so I'm just going to give you some example of what I have learned in these years, because what we want to do at the end of the day is to see if we can learn from nature, but then bring this ability into a system that can develop an industrial process of production, which is challenging as well. So at the end of the day, we would like to have our microorganisms to eat something that we can then develop in products that can substitute some of these materials, molecules, platforms that we are talking about that are running, let's say, rare. And the residual biomass is important because then when we obtain this wide variety of substances, we know that we have a turnover of this biomass that is much more closer to the time frame that we need to use it. You know what I mean? Because if we start from fossil resources, we cannot reproduce fossil resources in a time frame that is compatible with our use. So this is very important. And this is what we do. So we go into nature and we look for from, let's say, oh, this is all gone. Okay, so you have to imagine even better. So you go into nature. So I'm not influencing you. You can go everywhere because microorganisms are everywhere. Then our favorite are a little bit east, but you can go for your favorite one. Some are stinky, some they produce flavors, so you can go for the rest. And then you have, there is really nothing. Anyhow, so you take this yeast and then you produce different things. And I'm just going to give you some example very quickly for the production of biodiesel, plasticisers, or nutraceuticals. So can you imagine? The more or less similar microorganisms can take something that we throw away and they can really produce something so different that we need so much. And for example, I'm talking about this, let's say, group of microorganisms because I think they are super funny. So they are called Oleaginous because they become fat. When do they become fat? Because when we grow them and what is, let's say, okay, so here you have imagine everything again. So when you grow them and you give them a carbon source, so organic matter that is balanced, they grow. But when they find something like sugars or a lot of organic carbon that is in excess, they cannot really divide because they need also the nitrogen to do the DNA, the protein, these kind of things. And so what happens is that they take the carbon and they store it into fat, into lipid droplets. And so they become as fat as that I cannot even precipitate them because they just float, yeah? Because they are so good that, they can become as fat as the 70% of the cell-dry weight, which is a lot. And out of that, we can produce our product of interest. So it's a pity. I hope you can see some pictures now. So I give you one example, which is really nice. So start from the sugar beet, where we take sugar from. So we produce sugar. Yeah, let's say that 2/3 of these usually is lost. Molasses, some we can use for some sweeteners or some, let's say, procedure for producing food, but sugar beet pulp, it's really lost. And then what we can ask to this beautiful yeast that you cannot see, this is bad, to take the substrate and to transform it in some oil, which are very, very similar to the oil that you extract from oil crops. That means that you can have biodiesel. And this is very interesting because then you are not using the crops that are also important for our food chain. And you are not using the land that you would use for crops. So this is interesting. And so the other production, yeah, this is really bad. Yeah, there is nothing. Okay, I don't know why. Okay, but so let's say that now you might say, okay, is this, let's say, sustainable? Yes, but please consider that when you are producing biodiesel, again, you have a biomass, or let's say a byproduct, which is crude glycerol. And the crude glycerol is 10% of the biodiesel that you produce. So it's another residue. But there are other yeast, again, oleaginous, that can eat this crude glycerol and can do other products out of that. So you see, you can always consider that a byproduct can become a substrate for some other microorganism. And then according to their metabolism, you can really try to funnel these metabolisms towards the product that you are more interested in. And so I think this is something that should be put together with all that we said in these days. And let's see if it functions, this example. Yeah, there is not really a lot, but here you can see something. For example, in this case, we have crude glycerol. I just explained you where it comes from. And then we use our fat microorganism. And what is beautiful of this one that we selected is that they can produce omega-3 fatty acid, which we all know are all very good for our diet, but they are also very good for the diet of fish. You know that fishery is not enough for, obviously, let's say, the supply chain, and will be more and more in the future. So we have aquaculture. But what fishes in aquaculture should eat? The big fish are the fishes, and the smaller something, something, something. At the end, they should eat what they eat in nature. So if you want to feed the fishes in aquaculture, you should feed them with fish oil. Yeah, and then at the end, because you needed the fish for the fish oil for the fish feed. But then if you can take these nutritional additives from someone that is growing on a byproduct that is even not connected to the fishery and this aquaculture, then you can prepare a fish feed that is much more balanced. And then we also, with the University of in Subria, we prepared with a pilot some fish feed, and they could prove that the fish fillet of this fish is much, much better in terms of nutritional traits. So this is something that can really come much closer to us. And it also talks about industrial symbiosis that we mentioned yesterday. So it's really connecting two kind of, let's say, supply chain or industrial chain, which are not connected actually, because biodiesel and fish feed, they are not connected, but we are sharing the same field, sharing the same planet, I would say. And again, because I wanted to finish with material, and finally you can see my yeast, there is another one that is producing another kind of oil, which is like a plasticizer. And with this, we prepared a new compound that was used to prepare a tire. And the property of this tire were really very, very similar, and in some cases even better for some traits, in respect to the one that is prepared with mineral oil. So again, we are using something to supply to a supply chain which is using something that is becoming rare, and it also goes to material. And obviously with this kind of rethinking, you can also consider that these material, because of these elements, are also more prone to be biodegraded at the end of their life, which is also so very important. This is what we call rational by design. So we start rationally thinking also at the end of life of our projects, our product that should restart. And so I hope I didn't take so much of your time, and I just leave you with the last inspiration. And again, you see, I go back to time. So we are here in 1863, and the first ecologist, I would say, Alexander von Humboldt, was saying that everything is interconnected and interdependent. So I, let's say, beg you to not to, underestimate any level of this planet, and not making distinctions of hierarchies or whatsoever, because we need everything and we need to work together with our planet and not against. And so I thank my East, and I thank you for your attention, and my beautiful group in Biotech Lab, where we develop this kind of research. Thank you very much.